Hi, I'm going to share some ideas on RxJs. It is a library for composing asynchronous and event-based programs by using observable sequence. It provides one code type observable, satellite types observer, schedulers, subjects, and operators. Terms in RxJs. Observable represents the idea of an invocable collection of future values or events. Observer, it is a collection of callbacks that knows how to listen to values delivered by the observable. Subscription represents the execution of an observable, is primarily useful for cancelling the execution. Operators are pure functions that enable a functional programming style of dealing with collections. Subject is equivalent to an event emitter and the only way of multicasting a value or event to multiple observers. Schedulers are centralized dispatchers to control concurrency, allowing us to coordinate when computation happens. Example, set timeout or request animation frame or others. Using observable as event listener. Instead of using document.add event listener, from event can be used to add an event listener. Here a click event handler is added to the document object. Purity. Normally an impure function would be created in some scenarios. For example, here count state is maintained outside the event handler. Using RxJS, we can isolate the state. The scan operator takes a value which is exposed to a callback. The returned value of the callback will then become the next value exposed the next time the callback runs. Flow. Some operators control how events flow through your observables. Now consider the previous example where we printed clicked count to console log. If we want to allow at most one click per second, then we can use throttle time. Values. We can transform values passed through your observables. For example, here the user mouse X position is added to the count and printed on every click event. Observables. Observables are lazy push collections of multiple values. For example, here we are creating an object of observable and passing a callback method. The callback method receives a subscriber object as an argument, using which we can feed values to the observable source. When the observable is subscribed, we can pass an object containing three properties, next, error, and complete, all reference a function, which will be called when the next method on the subscribed object is called, when error is thrown, and the complete method is called on subscriber respectively. Pull versus push. Push and pull are two different protocols that describe how a data producer can communicate with the data consumer. In pull systems, the consumer determines when it receives the data from the data producer. Every JavaScript function is a pull system. The function is the data producer, and the code which calls the function is consuming it by pulling out a single return value from its call. In years 2015, iterator is a data producer, and the code which calls the iterator is the consumer pulling out multiple values. In push systems, the producer decides when data must be sent to the consumer. Promises are the most common type of push system in JavaScript, as promise decides when it delivers the resolved value to the callback, that is the consumer. Observables are push systems. It is a producer of multiple values, pushing them to observers that are consumers. While function and generators synchronously return single and multiple values respectively, promise returns a single value asynchronously. The observable can return multiple values synchronously or asynchronously. Observables are like functions which accept zero arguments and return multiple values. It is not an event emitter. For example, when we call observable.subscribe again, the numbers 1, 2, 3, 4 are printed again, equivalent to calling a function. Both functions and observables are lazy computations. Calling observables or functions multiple times triggers side effects multiple times, as opposed to event emitter, which share side effects and have eager execution regardless of the existence of subscribers. Anatomy of an observable. Observables are created using new observables or a creation operator, are subscribed to with an observer. Executed to deliver next or error or complete notifications to the observer, and their execution may be disposed of. The observable constructor takes one argument, the subscribe function. Observables are created using operators like of, from, interval, etc. Observables can be subscribed to by calling subscribe on it. For example, this observable will return a formatted time string every second. The observable is created using the observable constructor, and it is subscribed by subscribe method call. Executing observable. The function passed while creating an observable object is executed only when an observer subscribes to it. There are three types of values an observable execution can deliver. Next, send a value of any type. Error, sends a JavaScript error or exception. Complete, does not send a value. Next notification can happen multiple times, whereas error and complete notifications can happen only once during observable execution, and there can be either one of them. If either complete or error is invoked on the subscriber argument, then the next notifications called after are not delivered. For example, here complete is called before calling next with argument 4, so only 1, 2, 3 values are delivered. It is a good idea to wrap any code in subscribe with a try catch block that will deliver an error notification if it catches an exception. For example, the same example is written with try catch. Disposing observable executions. While calling subscribe method on observable, it returns a subscription object. This subscription object represents the ongoing subscription and can be cancelled by calling unsubscribe method on returned subscription object. For example, a subscribe call on observable returns a subscription object. We can call unsubscribe on the subscription object later. Optionally, the method which is passed to the observable constructor can return an unsubscribe method. When we call the unsubscribe method on subscription, the returned function from the method that we passed to the observable constructor is called. For example, the same time format example can be written as the following. In the method passed to the observable constructor, we finally return the method which will be called when we call unsubscribe method on subscription object. In that method, we are clearing the set interval timer. Observer. It is a consumer of values delivered by an observable. Observers are set of callbacks, one for each type of notification. Next, error, complete, delivered by the observer. We pass observer object to observable object subscribe method call as an argument. An observer object may not have property for every notification. The observable will skip execution of a particular function if it is not found on the observer object. The format of the observer object is shown. In the subscribe method of observable object, we can also pass the next callback function directly as shown in the second code snippet. Operators. They are the essential pieces that allow complex asynchronous code to be easily composed in a declarative manner. Operators are functions. There are two kinds of operators. Pipeable operators. They are the kind that can be piped to observables using syntax observable instance dot pipe of operator or observable instance dot pipe of operator factory. Operator factory functions include filter off and merge map off. When pipeable operators are called, they don't change the existing observable instance. Instead, they return a new observable whose subscription logic is based on the first observable. A pipeable operator is a function that takes an observable as its input and returns another observable. The input observable stays unmodified. Subscribing to the output observable will also subscribe to the input observable. A pipeable factory is a function that can take parameters to set the context and return a pipeable operator. The factory's argument belongs to the operator's lexical scope. Pipeable operators are like functions. They could be used like ordinary functions, for example, op2 of op1 of OBS. This style of coding will create an unreadable code, so observables have a method called pipe that accomplishes the same thing while being much easier to read. It can be written as obs.pipe of op1 of op2 of. Creation operators. They can be used to create a new observable. For example, of operator can be used to create an observable. Typical example of creation operator would be the interval function. It takes a number as input and produces an observable as output. For example, here the subscribe method will be called every second. Higher order observables. Observables of observables are called higher order observables. We can convert higher order observable into ordinary observable by flattening. For example, here http.get returns an observable, creating an observable of observables. It can be flattened using concat all operator. The concat all operator subscribes to each inner observable that comes out of the outer observable and copies all emitted values until that observable completes and go on to the next. There are other flattening operators: merge all, switch all, and exhaust all. Categories of operators. Operators are categorized as creation, transformation, filtering, joining, multicasting, error handling, utility, etc. Using pipe function to make a new operator. If there is a commonly used sequence of operators in our code, pipe method can be used to extract the sequence to a new operator. For example, here we create an operator that discards the odd values and doubles the even values. Pipe method is similar to pipe method in observable instance, but not the same thing. We can also create a new operator from scratch. For that, we can refer to any RxJs operator source code. Subscription. It is an object that represents a disposable resource, usually the execution of an observable. A subscription has one important method, unsubscribe, that takes no argument and just disposes the resource held by the subscription. For example, here we are calling unsubscribe on the subscription object returned from the subscribe method call. Subscriptions can be added to another subscription so that the call to an unsubscribe of one subscription may unsubscribe multiple subscriptions. For example, here multiple subscriptions are unsubscribed in the same unsubscribe call. Subscription also has a remove method in order to undo the addition of another subscription. Subject. An RxJS is a special type of observable that allows values to be multicast to many observers. While observables are unicast, the subject is a multicast. Every subject is an observable. We can subscribe to a subject. Subscribing to a subject does not invoke a new execution. It simply registers the given observer in the list of observers. Every subject is an observer. It is an object with method next of value, error of error, and complete. To feed a new value to the subject, just call the next the value and it will be multicast to the observers registered. For example, here we are creating a subject object. We are subscribing two observers to the subject object. When we feed values to the subject, it gets multicast to all observers. Since the subject is an observer, we can pass the subject as an argument to the subscribe method in observable. For example, instead of using next to feed the values, the subject is passed to the subscribe method of observables. With this approach, we are converting a unicast observable execution to multicast through the subject. There are also few specializations of the subject type: behavior subject, replay subject, and async subject. The same example can be written using a multicast operator. Observers subscribe to an underlying subject and the subject subscribes to the source observable. Multicast return a connectable observable which is simply an observable with the connect method. Connect method determines when the sad observable starts execution because connect does source dot subscribe of subject and returns a subscription. Reference counting. Calling connect manually and handling the subscription is often cumbersome. We want to automatically connect when the first observer arrives and automatically cancel the sad execution when the last observer unsubscribes. For example, we can consider an example where we create an observable using interval of 500. So it will generate values 0 at 500, 1 at 1000, 2 at 1500 and so on. We are subscribing the first observer to the multicast object and calling connect immediately. The first observer receives value 0. At 600 millisecond, we are adding the second observer. So both first and second observer receives the value 1 at 1000 milliseconds. At 1200 milliseconds, we are unsubscribing the first observer. So at 1500 milliseconds, the second observer receives value 2. Then we unsubscribe the second observer and connect subscription. If we wish to avoid explicit calls to connect, we can use connectable observables ref count method which returns a observable which keeps track of how many subscribers it has. When the number of subscribers increases from 0 to 1, it will call connect which starts the sad execution. Only when the number of subscribers decreases from 1 to 0 will it be fully unsubscribed, stopping further execution. So the same example can be written with ref count without manually calling connect and unsubscribe from connection subscription. Behavior subject. It has the notion of current value. It stores the latest value emitted to its consumers and wherever a new observer subscribes, it will immediately receive the current value from the behavior subject. For example, here we are creating an object of behavior subject and assigning the initial value 0. The first subscriber subscribes and get the initial value. Then we are feeding the values 1 and 2. Then the second subscriber subscribes to the subject, it receives the value 2 even though it is subscribed after feeding the value 2. Replay subject. It is similar to a behavior subject in that it can send old values to new subscribers, but it can also record a part of the observable execution. When creating a replay subject, we can specify how many values to replay. For example, here we are creating an object of replay subject with buffer 3, that is up to the latest 3 values will be sent to the new subscriber. Then the first subscriber subscribes to the subject. Then we feed values 1, 2, 3 and 4. Then the second subscriber subscribes to the subject. The second subscriber receives the values 2, 3 and 4. We can also specify a window time in milliseconds besides of the buffer size to determine how old the recorded values can be. For example, here we provide a bigger window size but only 500 milliseconds for the time parameter. Async subject. It is a variant where only the last value of the observable execution is sent to its observers and only when the execution completes. For example, here only value 5 is sent to its observers. Void subject. Sometimes the emitted value does not matter as much as the fact that the value was emitted. For example, here the subscribed method will be called after 1 second and does not require any value. Scheduler. A scheduler controls when a subscription starts and when notifications are delivered. It consists of three components. A data structure. It knows how to store and queue tasks based on priority or other criteria. An execution context. It denotes where and when the task is executed. A virtual clock. It provides a notion of time by getter method now on the scheduler. Tasks being scheduled on a particular scheduler will adhere only to the time denoted by that clock. For example, we use simple observables and emit values 1, 2, 3 and use the operator observe1 to specify the async scheduler to use for delivering those values. Here, after subscribing message will be printed first before got value messages. The async scheduler operates with a set timeout or set interval. All the time related operators follow scheduler internal clock, not the wall clock time. Schedule types. Null. By not passing any scheduler, the notifications are delivered synchronously. Queue scheduler. Schedules on a queue in the current event frame. ASAP scheduler. Schedules on micro task queue, which is same queue used for promises. Async scheduler. Schedules work with set interval. Animation frame scheduler. Schedules tasks that will happen just before the next browser content repaint. Using schedulers. All observable operators that deal with concurrency have optional schedulers. If a scheduler is not provided, RxJs will pick a default scheduler by using the principle of least concurrency. Some creation operators take a scheduler as an argument. Use subscribe on to schedule in what context the subscribe call happens. You may delay or schedule the actual subscription to happen on a given scheduler using instance operator subscribe on of scheduler. Use observe on to schedule in what context notifications will be delivered. Thanks. If you find this video valuable, you may share it with others. If there are mistakes, please mention them in the comment section.